Hello and welcome to today's webcast, Innovations in Telecom Room Architectures, New Solutions for Today's Network Challenges, presented by Thomas Baum, Senior Product Manager with Panduit Corporation. Panduit is sponsoring this seminar. We thank them and Thomas for making the seminar possible through their sponsorship and for providing the technical information that you'll see today. In today's presentation, Thomas Baum will examine some innovative approaches to managing telecommunications room architectures. He'll focus on aspects of TR management that can be easily changed and can bring immediate benefits. The presentation will include patch panels, patch cords, horizontal cable management, and rack layouts. Partway through the presentation, Thomas will be joined by Dan Maynard of Nationwide Insurance. Nationwide has implemented some of the architectures that you'll hear about today, and Dan will share his first-hand experience with them. Please use the red button at the bottom of your screen to ask questions of our presenter. We'll have a Q&A session with Thomas at the conclusion of the presentation. You can also use that red button if you have a technical question about this broadcast that is not answered via the gold help button that's also at the bottom of your screen. If you plan to use your attendance today to earn a continuing education credit for a BICSI professional accreditation, I will walk you through the process of receiving that certificate once the presentation is complete. So thank you once again very much for joining us today, and I'm pleased to introduce today's speaker, Thomas Baum. Thomas, whenever you're ready.
Thank you very much, Patrick, and hello, everybody. Our topic today is innovation in telecom room architectures. And whenever you talk about innovation, it should be both new and exciting. And that's the goal of this presentation today. Not only are we going to show you 5 new infrastructure solutions that we're seeing in telecom rooms, we will also, compliments of Dan and Nationwide Insurance, take a close look at a real-life case study where some of these have been used, and we'll see the results. And these innovations are exciting because they address common telecom room challenges, and they can be put to use today in many TRs. But to start with, why are we seeing innovations in telecom room architectures? Haven't telecom rooms been basically the same for years? Well, whether you've been in the IT network space for decades or just a couple years, you probably agree that there are a constant stream of changes, and some would even say there's never been more change happening than right now in the typical enterprise network in telecom rooms. We'll discuss these changes and how they create new challenges, and how it is those challenges which are driving the need for innovative new solutions. Also, today our focus will be on easily changeable aspects of the TR infrastructure, such as the components used, patch panels, patch cords, managers, etc., within the rack, or their placement within the rack footprint. That's to ensure we're presenting realistic solutions that can be implemented within existing rack footprints and spacing, since we all know that those are not easily changed. Also, because copper cabling, whether for patching, horizontal cable, or for connecting switches or other equipment, plays a large role in most enterprise TRs today, the infrastructure solutions you'll see will be focused in that area. A good starting point, though, for discussing innovations in TR architectures is to provide a baseline of sorts for some common elements seen in many TRs today, several of which may be challenged or changed within the 5 innovations that we're going to be reviewing. Here you can see a very common large TR rack configuration featuring elements like a general 2-rack layout, liberal use of 24-port 1RU flat patch panels, numerous horizontal managers, typically, very common, all patch panels mounted horizontally, available space within the room. You might have quite a bit of space outside of the rack, and generally you might have quite a bit of space open within the rack. Very typically today, and many of the legacy installations across the country, the use of 24-gauge patch cords, and usually discrete patch cord lengths that are different, right? Just to map out to the kind of the layout that you see in front of you. And finally, even in a large enterprise, typically there being some variation maybe among the telecom rooms, either their layouts or their patching practices and so forth. So let me just say right off, there's absolutely nothing wrong with this layout or these features. But as we discuss the changes in the network and the challenges they create, it becomes more a question of whether features like those above are the best way to address the new challenges. Let's look now at the major changes occurring in the network and its infrastructure. First off, there's the transition from Category 6 to 6A cabling, which typically brings a 35% increase in the volume of that the cords take up from a patching standpoint, as well as horizontal cabling for UTP networks. And I'll just mention that those images are actually to scale in terms of the size of an individual cord. There's also the convergence of lots of new IP-based equipment into the existing TR space. Wireless access points, security devices, maybe even some IP lighting going in, different degrees of building automation, etc. And all of this is bringing, of course, new equipment that goes along with it that's expected to be housed in the TR. We've seen a move toward large chassis switches and higher density switches. The one pictured there is a very typical switch in the large enterprise. It's actually a Cisco 4510 series switch, and we'll be using that throughout several of the innovations because it's quite common in the industry today. As we've discussed before in a webinar about 6 months ago looking at just 28-gauge patch cords, we're seeing, of course, more confined and more limited space being allocated to TRs. And finally, something that is a bit more of a practice mentality and a philosophy that we're seeing with many large customers is the acceptance and the need to churn these telecom room closet locations and configurations. I'm sure many of you who've been in the industry for some time, the TR room location may have stayed the same and the physical layout may have remained essentially unchanged for long periods of time. But with many large customers today, what we're seeing is customers who take a philosophy that the enterprise and the needs of the enterprise are what are paramount. And if that TR has to change rapidly to scale up or scale down to allocate large shifts of people, that they're doing this quite frequently. So these are big changes. And these changes create many challenges. Obviously, we've got a challenge of managing larger cable sizes in the same space because of that general Category 6 to 6A transition. We also have to create space in that existing footprint that we have for those more pieces of equipment that we mentioned, and the fact that the equipment in many cases, such as the large chassis switch, because it's incorporating redundant power supplies and so forth and supervisor blades, that the equipment is larger and we're seeing more ports. The management of these higher ports and densities at switches and panels is something that is a challenge as well. And as we see in the picture there, it can result in cabling and cord densities such as you see. And finally, relative to that need to rapidly churn and change TR rooms and scale them up and modify them, there's this need to set up or reconfigure telecom rooms very quickly, as fast or faster than before. So it really boils down to challenges of space and time. And these are the two key areas of challenge that we see in the industry, and the challenges that the innovations will address. I mentioned 5 new solutions. Those 5 are the following: rapid patching, rapid port replication, direct switch patching, also known as one-to-one patching by some in the industry, high-density configurations, and vertical patching. Now, I'm sure you're asking for some or maybe all of these. What are those? Well, we're going to walk through each one of these, and for each case, we're going to look at a description of what it is, where you would use it, what you would need, what infrastructure components you would need to implement it, and what you get by using it. So, without waiting any further, let's jump into our first innovation, which is rapid patching. Now, in this scenario, we've got a typical 2-rack layout. We've got 2 of those chassis switches on the left, and we've got a field of matching patch panels on the right. And what we want to do in this case is patch from one of the switch line cards, there you see highlighted, to one of the patch panels on the right. Now, with rapid patching, what we're doing is using a pre-assembled multi-cord patching harness that is taking us with a group of cables, a group of cords, from the switch side to the patch panel side. Now, if we do this using a 12-cable assembly, as you'll see in a moment, we can do 1/4 of that line card at a time. If we replicate that 4 times, bam, we've just now patched that entire RU in a much faster way than previously. So where you would use this is to reduce the patching time to speed the deployment of the typical 2-connector telecom room layout. And this is really best used when it's matched with the same length cord layout, so that those harnesses can all be the same length. And as you can see, that would be the case here. And here's what this looks like in a real-life scenario. You can see that on the left side rack in the picture, the 4510 switches are there, and then matched RU for RU are the 48 high-density patch panels with the harnesses mapping between them. Now, the ingredients for this solution are a plug-to-plug switch patch harness, and ideally that's using 28-gauge cords and a switch end organizer. The switch end organizer is that housing assembly that's in the lower left of the picture, and that's used to facilitate one-handed quick install of all 12 ports into the switch end, with the loose cords being on the patch panel end. Also, we'll be using 48-port 1RU panels. And the 48-port 1RU is key because it allows us to have that same length configuration and match up to the switch line cards, which are 48 ports and 1RU. The benefits that we and customers see with this approach is a 60 to 85% time savings versus loose cord patching. That's coming from the fact that with a plug organizer on the switch end, you can install 12 or 6 or 12 cords at a time into the switch, but you also are running one bundle over of 6 or 12 cables, and that's saving quite a bit of time. It enables a more compact layout, and it provides consistency between TR sites. There will be a time for questions at the end, so please, as we're talking, because we've got a lot of ground to cover, please note those questions, and we'll be happy to address them as many as time allows at the end. In our second innovation, we'll look at rapid port replication. Now, this looks similar at first. You can see in the left side rack that there are 2 chassis switches. In this case, though, we've got a field of patch panels above which we'll be populating with an equipment cord going from the switch line card up to a corresponding set of panels to replicate the switch ports. This is typically done when a customer wants to isolate the switch and protect those switch ports from access so that the ports can be replicated in the panel above. Now with rapid port replication then, what we're doing is again using a pre-assembled multi-cord port replication harness, which many of you will know as an equipment cord. It's a plug on one end into the switch and a jack onto the other end. In this case, we'll be going from the switch line card up above to the panel from the back. And if we do that again in a group of 12, we can then replicate that 4 times. And literally within minutes, you can have replicated an entire RU of ports. The application case here is to reduce the port replication time and speed deployment of typical 3-connector TR channels or TR layouts. And the port replication here, of course, would be used to limit the access to those switch ports. Apologize, the advancing. Here we go. And here's what that looks like in real life. These are actual customer photographs. In this case, we're looking at, in the left side view, we're looking at a case where the switch has been turned around, and at the bottom you can see the patching into the switch with the cords then going up, and then we're looking in the top of that picture into the back of the panels. On the picture on the right, we see what that looks like from the front, where you would actually have your cross-connect field with the replicated ports on the left and your horizontal cabling ports on the right. The ingredients, component-wise, that we use for this solution are a plug-to-jack replication harness. Again, ideally using the 28-gauge cords because of the space advantages they provide, a switch end organizer to speed the installation into the switch, and ideally a cassette of jacks on the end that will go into the replicated port panel. And that cassette of jacks is what allows us to really reduce the amount of time on installing the ports into the panel. Ideally, we will also use 48-port 1RU panels that can be vertically numbered just to match the exact switch port mapping, since switches normally are numbered vertically. The benefits seen in this application are even more time saved generally, and you might ask, well, why is that versus loose cords? Well, typically there is the running of the equipment cord from one side of the rack to the other. So typically there's a little more dressing required, and therefore the time savings is greater when the cords are bundled together. This also can increase the consistency between telecom room sites and make it very easy for installers to achieve a consistent implementation. Let's change gears here. We've talked about a couple installations with the 4510 chassis switch. Let's take a look at an application where you'd have an edge switch, a 1RU rack-based switch. You might have several of those together, and you're looking for the best way to patch those. This is where we see the application of direct switch patching. From one particular switch to an adjacent panel, either directly above or below it. And what we do in this case, the direct switch patching is a short patch cord used directly between the switch and the adjacent patch panel. You can see that small line coming up there. And typically, we're going to patch sets of ports that way. And as we continue that process, we'll build it out until we populated all the ports directly above or below the switch. And the application case here is if you have individual multiple edge switches with the panels right next to the switches. Now this solution creates space in existing racks for new equipment because it obviously eliminates a horizontal manager, or it can be a compact layout for new racks, or even like a half rack or a wall-mounted small rack that you might have. So this is for a little bit different application, but you can see the space savings that immediately result from that. And here's what this looks like in practice, and I can tell you that this is an actual customer photograph from a specification that they have settled on, realizing that this is the most dense and the most easily implemented configuration for edge switches. The ingredients for this are really pretty simple. You have short patch cords with 8-inch lengths being typical, and ideally these are 28-gauge cords. The reason for that 28-gauge cord here is that we are putting, as you see in the lower left picture, we're putting cords directly above and below, running directly above and below, and we're counting on the fact that you can easily manage in that space. This is where the size advantage of those cords, being able to view the port numbers and get your fingers in between them, is where the 28-gauge cords really stand out. You're also using a 48-port panel, although it may be either a 1RU or a 2RU, typically vertically numbered, again, to match the port mapping on the switch. In this case, you've already gained quite a bit of density from the use of eliminating the horizontal manager, and some customers find it, frankly, easier to work with a 2RU panel in this case. The benefits, obviously, you can reclaim usable rack space for new equipment, and this can be done very quickly through the elimination of that horizontal manager. Typically, it's going to save you at least 2U per switch. Obviously, you also eliminate the cost of horizontal managers if you're looking at a new install. And in terms of an operations cost, it's much easier maintenance and troubleshooting because there's literally no cable to trace end to end. The entire link is right there in front of you. So this is something that's gotten quite a bit of attention as a very quick to implement solution. Now let's take a look at a little bit of a tougher problem. And this is our number 4 solution, which is the high density configuration. Now, you might need a high density configuration where you not only have a couple large chassis switches, as we see, but you might need to incorporate all of the patching for those switches in one rack for one reason or another. Maybe you need to temporarily add a large switch for a cutover, and you only have one rack to do it. Or maybe, just due to your limited space, you've got to consolidate into a single rack all this equipment. So in this case, what we're talking about is really more of an overall configuration. It's a layout, and it combines the 2 chassis switches that I mentioned, you see there in blue. It combines angled patch panels into the center. You might ask, well, why angled panels? Well, we want to remove every unnecessary RU that could be used for horizontal managers. And the angled panels allow us to do that so that we can make maximum use of that patching space. We are going to use a horizontal manager, and I'll tell you why in just a moment there. Really, usually it's for the cutover or the crossover of cables from one side of the rack to the other. And we were able to get away with a 3U horizontal manager because we're using our 28-gauge patch cords again. And the small size of those cords allows us to take half the quantity from one side to the other. If we want to observe a very typical practice with these 4510 switches of patching and running the cords, dressing them just to the right side vertical manager fingers. Finally, you may or may not need a 2U rack extension that you can place on top of the rack. And you can see that in the aqua-colored box at the top. Let's say you've got just a few pieces of additional equipment. Maybe it's a distribution switch. Maybe it's a fiber tray, a WAN device, something like that. But you might need just a couple extra RU than you have available in the rack, and you can take advantage of that space above the rack. The application here, obviously, is high patch port capacities within a single rack using conventional, meaning horizontal, panel orientations. For example, in this case, what you're looking at is enough RU in the switches and the panels and the horizontal manager to accommodate 672 ports. This can even scale up a little bit higher, as we'll see in a comparison between all solutions at the end. And what this looks like in one of the key areas of a high-density patching configuration with multiple angled panels is something like you see in these two pictures. The larger picture shows what that looks like when using 24 in 1RU panels. And the inset shows what we get when we use 48-port 1RU layouts in the angled panel. So the ingredients, component-wise, for this solution, certainly the use of 28-gauge patch cords are recommended. The reason for that is right there in the pictures. Whether up top or below, you can see that the size of the cords enables you to, when using a high-density 48-port 1RU panel, enables you to easily see the port numbers, as well as work with the cords and decrease the patching bulk that goes to either side into the vertical managers. Certainly the angled panels that we discussed, and possibly, as I mentioned, a 2U, or it could be even up to 4U rack extender that would go on top of the cabinet or the rack. And finally, a horizontal manager that, in the case we looked at, a 3U would be the appropriate size. The benefits here, as we started with, it provides the highest port density in a single rack using conventional panel orientation. Now we're on to our fifth and last innovation, and this one is vertical patching. Now, you might have a need for even more patch port capacity in a single rack than what we just looked at. Maybe you've got to support multiple large switches, or maybe you're simply being asked to consolidate into a single rack this amount of equipment. Now, I'll say that we're going to look at this scenario in a maximum port capacity sense, but vertical patching can be used simply to add additional patching capacity or equipment availability into a vertical manager that's simply in addition to what you may have in your horizontal panel orientation in a rack. So it doesn't always have to be used this way, but we're going to focus on it as an absolute maximum port density in a single rack. So once again, this is going to be an entire layout, and it's going to combine the following elements. Multiple chassis switches. In this case, it's actually 3 of the same 4510. They're 14 RU each. In the center of the rack, here in the teal color, you can see that we're using vertical managers with panel mounting capability within the managers, meaning vertical panel mounting capability within the managers, which not all vertical managers have. They have to be specifically intended for that purpose. In the yellow, you can see that we've got our vertically mounted patch panels. Here again, these ideally are 48-port 1RU panels because we want to take maximum advantage of this limited space within the vertical manager. And finally, looking at how you might patch between switches, from switches to the adjacent set of panels, we certainly want to be using 28-gauge patch cords here because, as you'll see, the patching density gets quite high in this application. Which what we're doing here, the goal is maximum patch port capacity where that's needed, and where vertical mounting of the panels is acceptable. This actually can get you just over 1,000 patched ports, as we're showing in this scenario. Each switch has 7 line cards of connectivity, with the rest being used for supervisors and managers. And we have a total of 21 patch panels, 48 1RU. So we're able to patch all of those cords. Now, looking at what this looks like for the vertical manager element, or the vertical patching element, because this tends to be one of the new things. Here you can see in these two pictures the panel mounted vertically, and to some degree the challenge that comes with the patching in this case. The ingredients we have here are vertical managers with panel mounting features to mount the panels vertically. We certainly want to be using those 48-port 1RU panels, and we also want to be using those 28-gauge patch cords, which are used in the illustrations that you see, because we want maximum flexibility, maximum density of the cabling, and ability to dress it, since we're going in this vertical orientation. The benefits of this application is providing that additional space when you might need just a few patch panels, or you might need a large number of panels within existing racks. This also provides the highest available RU for equipment in a single rack. I will say, though, just in fairness, that as you can probably imagine, the patch cord management in this can be a challenge at that maximum density level. We've now looked at 5 different scenarios, 5 different innovations. Now let's come back to those challenges that we mentioned that were mainly challenges of space and of time. And we're going to compare all 5 of the solutions relative to their speed of deployment and the density that they provide. For density, for this slide, we're going to measure that in maximum patched ports in a single rack. The range here you see we're covering is from 240 up to 960 or greater. 240 today is a typical kind of capacity that you might see in a normal rack layout today, 240 or 384, multiples of 48. And by patched port capacity, what we mean here is the combination of the switch ports that are resident in that rack patched up to the corresponding point where the patch cord or equipment cord plugs into the panel. For speed, we're going to focus on the speed of patching. We're going to look at the time to patch 1RU, meaning 48 ports. Generally, that can run from as much as an hour or a little bit more using loose cord patching. This is very typical. 48 cords, a little over a minute a cord, running end to end. You can easily achieve an hour, and that's typically what we see. On the low end, and we'll see this in some of our solutions, you can cut that to a third. So 20 minutes time to patch 1RU. So let's take a look now at where our solutions lay out. And I'll just tell you that these are not exact, because obviously I want to be able to show each one, but you'll get the idea of this. And the point here is to really consider how these solutions stack up to each other. With rapid patching, it certainly is very fast, and that's one of the main advantages of that approach. But you can also achieve fairly high patch port capacities because of the ability to use high-density panels very easily, up to about 480 ports in a single rack. In our second solution, the rapid port replication, really we might overlay it exactly on top of it in terms of the time. You save that much time, or maybe even a little bit more, because of the time savings of typically routing to the back of the panel and the ease of doing that with a bundled harness. And it also can accommodate about 480 ports in a maximum case in a single rack. Each one of these that we're looking at are consistent with the layouts of the slides that we looked at previously. Moving on with our direct switch patching. Wow. Now we've really shifted the density, you can see, with it covering everything from in the mid 300s up to even 960 ports, patched ports in a single rack. It's also fairly fast because, as you can remember from the direct one-to-one patching, there's no manager to use. The cords are very short, and you're holding in one hand both ends of the cord at a time. This is a little bit misleading in terms of saying that you could accommodate 960 here, because typically you would use this for edge switches, and usually you're not looking at that many switches in a single rack. So the point here is that you could, but you probably wouldn't use that many ports in a single rack. Our last two configurations have the main advantage of density, addressing the space and the amount of equipment to go in. Our high density topping off at around 768 ports in a single rack. And then, as I mentioned previously, our vertical patching configuration, where everything is maxed out, we're taking maximum advantage of the space beside the rack to achieve over 1,000 patched ports. So let's move on now to the good stuff and look at the actual implementation with Nationwide. And we're very pleased to have, again, Dan Maynard of Nationwide Insurance with us. Dan, are you still with us?
Yes, Tom.
Okay, thank you so much. Now, Dan is a specialist for infrastructure engineering for network and LAN operations in Nationwide, and he's responsible for the decisions on infrastructure used in their telecom rooms. Did I get that right, Dan?
Yes, sir.
Okay. So, Dan, to orient us on your typical IDF configuration within your TRs, it might be helpful if you walked us through what some of the key points are of your IDF configuration.
Well, depending on the number of horizontal drops to the IDF, we use 2 to 3 racks, the 4 to 6 inch vertical managers. With the angle patch panel, that alleviates the horizontal wire managers to use. Typical IDF equipment, it's usually a Cisco 4510, UPS to the first power supply, eliminates spikes, and the second one is house power with generator backup. And we have, in the second rack, several RUs for future equipment. The need for a third rack, that would be another switch and angle patch panels so the switches aren't ventilating into each other.
That's great. Thanks, Dan. Now let's focus on the challenges. You and I know the challenges you were having before with the IDS, but again, for our audience, would you mind walking us through what those were?
So you can see in the first picture on the left, that's pretty typical after a lot of people gets their hands into with the moves, adds, and changes. It just congests the vertical manager and the switch, and we couldn't close the doors, and it just made it bad for moves, adds, and changes. If you had to change out a blade or something, it was merely a nightmare. And we didn't have really a lot of standardization throughout the enterprise. Okay.
Exactly. Some of the same things that we discussed previously as very common challenges. Now let's discuss, Dan, the solution that you use, which maybe some of our audience has already begun to guess at.
So when I was introduced to the new patching harnesses, we really liked the 6-packs with the 28 gauge wire. I use all the same length, 6 foot. This with the angle patch panel goes, say, switch blade 1, port 1 would go to port 12 on the patch panel, and then they descend like that. That way, all the cables fall evenly.
Which I'll just say, Dan, that's a great example of an orientation that allows you to use a single length assembly throughout, cutting down your inventory that you use, cutting down the time to have to find different length harnesses. So that's just is an excellent example of some things that we discussed earlier. So what kind of results, Dan, came out of that Nationwide saw?
Well, that gave me more space than my vertical managers. Was able to close the door. It was a lot nicer, clean looking. Time for patching a switch, like you said earlier, cut it like one blade down to about 20 minutes. My low voltage installers, they really like the 6-packs and the ease of use with cabling up a switch, which really saves me money too. Before I always had 2 guys at 4 hours, so that was double the labor, and it's it's becoming a constant configuration across all of my locations.
Thanks. And Dan, just on that time, I know you yourself actually patched up a 4 RU switch in like an hour and 15 minutes, something like that?
Yeah, it was about an hour 20.
Yeah,
like
so
that.
that's exactly in line with that 20 minute per RU level that these solutions can get to.
Yeah, I had to try to just justify the cost on it, so it was well worth it.
Thank you. So finally, Dan, I bet our audience would like to see some before and after views of the challenge areas and get your comments on the impact of the solution in each one of these. So I'll just flip through these and I'll let you just speak to the before and the after case.
Well, you can see where it's a nightmare there on the before, and then with the 6-packs, you can see how nice and clean it is.
So there's a win for us there in that area. Now let's look at the pathway working space.
As you can see now, we have them individually bundled instead of one big bundle, and it's easier to trace something out. Mm-hmm. And if you had, just like I said, if you had to change a blade or a fan tray out, you could see it really saves the time, where it might take you 8 hours, and here you would save a lot of time. With the quick connects, you could just unplug them straight from the blades.
Perfect. And Dan, what about looking at the last set of pictures in terms of the patching into the panels? We talked about the visibility at the panels and the density at the vertical manager fingers of the cabling. Any comments there?
Yes. Well, you can see it's a lot cleaner. It's a lot nicer. It's not bundling up a lot in the fingers on the vertical managers.
Mm-hmm. Great. So we'll count that as a win too. I guess overall, Dan, in your case, you had the challenges. You saw the solution. Would you say that the rapid patching solution using the 28 gauge cords met your expectations for what it was going to do for space and time savings for you?
Oh, yes. I mean, it definitely increased, saved time. I guess FTE time back, or my cable vendor, I save money with them because it's a lot easier and faster. My support guys, they like them because if they have a problem, they can do a quick, real quick disconnect with them or insert.
Terrific. Well, Dan, thank you so much. And folks, there you have it. One of our solutions actually in action to address the kind of challenges that we looked at. Dan, thank you so much for joining us. And I'm sure if the audience was patched in, we'd hear a lot of applause for you right now. So you're just going to have to take our word for it. Thanks so much.
Thank you, Tom.
Folks, you're welcome. So we've covered a lot of ground here. But before we close, let's do a quick recap of the components used in the solutions that we've discussed today. just in case you might want to write up a bill of materials later today for that next project. So we first off looked at pre-assembled harnesses, and those could be either switch patching harnesses, which is the top one, which would be plugs on both ends, and ideally some type of a quick connecting organizer on the switch end to maximize the time savings. Or it could be the switch, the port replication harness, either 6-way or 12-way, or even 8-way. And this would go from plugs on one end into the switch with jacks on the other. And again, for the maximum time savings, you'd want those jacks housed in a cassette so that you get that one-handed installation of 6 jacks at a time. Patch cords obviously played a big role, and we looked at the advantages in the incorporation in every case of the 28-gauge patch cords, either of the normal length that you might see, or in particular the short ones there on the bottom, with typically like an 8-inch length being used. You can use short cords of other gauges in that case because they are short. However, I think you'll find, and most of our customers find, that additional working space you get with the small cords really makes that very tight density configuration a lot more user-friendly. We looked at a number of patch panels, but the general theme there was 48-port 1RU patch panels of either flat or angled panels, angled because it helps us reduce those horizontal managers, and some of those panels being vertically numbered. And you can step back through the slide deck, which we'll make available to you at the close of this. You can step back through to see in which cases those vertically numbered panels came into play. We did look at one case with a 2RU 48-port panel, and that was our direct switch patching, just where some customers find that with everything going on with the switch right there, a 2RU 48-port panel might be a little bit more usable. And finally, we looked at a few different managers and accessories that were used to complement all of this and make these configurations happen. Things like a rack extender, just to buy a few extra RU on top of the rack, where typically you do have a little bit of available space. We looked generally at a 3U horizontal manager, which when using 28-gauge cords gives you enough space to transition half of the port capacity from one side of the rack to the other. And finally, we looked at that vertical manager with the vertical panel mounting features, which not every vertical manager will have. You do have to specify that. In terms of availability of all of these solutions, I can say, of course, that at Panduit we have all of these, but most are also available from other suppliers. If you have questions on that, please just contact your local salesperson or your local distributor that you work with. So how do we summarize so many exciting TR innovations that we've just seen? Well, the main takeaway is really this. These are all just options, and there is no one-size-fits-all. And please do not take that as a message from the 5 different configurations that we showed. The theme here is that they are all different approaches, and the key is that the solution that you use must fit the application. And while we focused on time and space as driving challenges, certainly there are other factors to consider beyond just the patching speed and the density. Things like the ease of cable management that you'll see. The amount of expected change with some of these configurations, in particular, say, a fully maxed out vertical panel configuration, not being the sort of thing that you will want to have a lot of change going on. You can achieve the high density, but it's not going to be so easy to maybe have changes over time. So you want to factor that into play as well. And then the time required in the planning and ease of deployment of solutions. Some of these solutions are very easy to deploy and very simple to plan. The easiest one being the one-to-one direct switch patching, but also the harnesses, whether the rapid patching or rapid port replication. It's a fairly easy planning that then is cookie cutter into your different TRs, and it's very easy to deploy. So again, all things to keep in mind. And finally, we'll just close with this. The fact is that changes are going to continue in the network. and they're going to drive new innovations in the network infrastructure. And we look forward to hosting future presentations with you to update on new things that we're seeing, and that we would love to hear from you about any new infrastructure solutions from those of you in the field. Now, as a reward for your attendance today, you will be receiving an email with reference to the Big C Continuing Education Credit. And in that, there's also going to be a link where you can request a free sample of Panduit's new Category 6A 28-gauge patch cord, which I hope you'll take advantage of. So thank you all so much for attending, and have a great day.
Thomas, thank you very much for that presentation. We're going to get to Q&A very shortly. Going to give Thomas a chance to catch his breath a little bit. But in the meantime, you see on your screen now a simple yes-no poll from our sponsors today, Panduit, asking if you would like to speak with a Panduit representative about any of the innovations that were explained in today's seminar. I want to say thanks to everybody who submitted questions to us today. We do have quite a few of them, and we're going to answer those that we can just as soon as we get into Q&A. But for the time being, we do just ask you to respond yes or no to this poll, simple poll question about whether or not you would like to hear from a Panduit representative about the technologies that you've seen today. I am going to advance one more slide here, and of course thank our presenter Thomas Baum, but also the illustration, the graphic you see here, in case you haven't already gotten there, is where you can find your attendance certificate today. On the bottom part of your screen you should see that rose-colored icon. Clicking on it should bring you to your attendance certificate. So with that housekeeping out of the way, if we have Thomas back, there were quite a number of questions that came in, Thomas. I would like to take the approach of, if possible, sending you at least one question about each of the 5 innovations that you discussed, and hopefully we may have time for another couple of questions after that. But at the very least, want to ask you at least one about each of the 5. Do we have you, Thomas?
Sure, we do.
Excellent,
we do.
Thanks. Thank you. Concerning the rapid patching solution, one question came in and asks, can that rapid patching solution be pre-labeled from Panduit with custom identifications, custom IDs?
Great question. Again, thanks to all the audience for the interest in the questions. Simple answer is absolutely yes. And let me push this out to the audience again to take a look at a common scenario. We as Panduit do quite a bit of custom labeling, and we will take that in the form of spreadsheets from customers. We have sheets we can provide you, and we've got the logistical capability within our factories to actually flow that information directly into the labeling and apply those, and even do some custom kitting in the sense of grouping sets of cords to really minimize the time that the end user, the installer, has to take to get to the right cord to go to the ports. I'll just say that if anyone, as many of you I'm sure on the line, actually do field labeling, you know that this is not the friendliest thing to do. Handheld labelers are great. Panduit makes them as well as several other manufacturers, but without that capability to flow the information in directly from the spreadsheet, it really is a huge time commit to label in the field. So yes, we can absolutely do that, and a great question. What's next?
Next, concerning port replication, asks, with port replication, what type of certification requirement are customers asking for the horizontal link? And the question says, not TIA. In other words, if there is not, it sounds like perhaps there is not a TIA sort of standard to which this could be certified. So when you're in the field in real life with real customers, what type of certification are they asking for?
Okay, So I've got the slide out about the port replication, and actually, what we're talking about with port replication is something which is incorporated in the TIA standard under the framework of the three connector channel. The TIA 568 C2 standard lays out three different allowable channels, those being 2-connector, 3-connector, and 4-connector channels. And with port replication, this very first link of cabling that we're talking about is simply the equipment cord. In TIA speak, it would be referred to as the equipment cord running from the switch to a jack, and then you would patch using conventional patch cabling from your first connector in the channel to your next connector in the channel, which would be the connector at the end of the horizontal cabling within the TR. So maybe I didn't explain it well enough earlier, but what we're doing here in port replication is simply what most customers do today in implementing a standard 3-connector channel. So the certifications and such would all be the same, and this would fall completely under TIA guidelines, and obviously observing the maximum channel lengths that you do for any copper channel.
Excellent. Thank you, Tom.
Thanks, Dan.
Question about innovation number 3, direct patching. Are the patch panels between the switches where the horizontal cable terminates, or are they replicated ports? If they are horizontal, how is wire management handled between the switches? So kind of a multiple part question for you there, Thomas.
Sure. Actually, maybe it's easiest in this one, Patrick, to go directly to the photograph. And again, in the view that we're looking at here, the silver the silver panels that we see interspersed are the switches. And in this case, the switch is at the bottom, and its adjacent patch panel that it patches to is directly above it. Now, it can also be positioned so that it's patched to the panel directly below it, but the only requirement is that the panel to be patched by the 1RU switch is directly above or below the switch. It's your discretion, customer's discretion as to which. Typically, this is also where the panels are vertically numbered, because as you can see, using the consistent length short patch cord, you're going to be going from the port that's in the corresponding area of the panel. There's not the length in the cords to switch between, say, a low-numbered switch port, like a 1 or 2 or 3, up to a panel port number that's 24 or 30 or something. The key is that you're switching, you're matching, doing one-to-one patching between panels in the same respective area from the switch to the panel. It is very simple, and it is what makes this so quick and easy to implement. I hope that answered the question there, Patrick, and let me know, please, if there was another element that I missed.
Thank you very much. I think that covered it. I am going to move on to a question I'm going to kind of put together that's a compilation of a number of questions that came in concerning high-density configurations, in particular 28-gauge patch cords. Number of questions asked about the implications of the forthcoming IEEE 802.3 BT, that next generation of power over Ethernet, where the number 90 is being used in terms of the amount of power being delivered or at least sent. Anyway, a number of questions kind of get around the idea of what's the story going to be with these 28-gauge cords and that next generation of power over Ethernet? Will there be compatibility? Will they be supported? Will they support next generation power over Ethernet?
Okay, Patrick. Again, great question. Boy, we've got a sharp audience today. Happy to see so many insightful questions coming in. Yes, PoE and PoE++, soon to be released standard. No pun intended, but it is a very hot topic, right? And I can tell you that absolutely 28 gauge patch cords, whether for 5E, 6, or Category 6A, will support the expected power levels in that range you just mentioned, Dan. We in fact at Panduit have a number of our own people who work within these committees, so we are well aware of the expected targets. The one consideration that I'll just make you aware of, and actually we covered this quite a bit in our presentation about 6 months ago on the 28 gauge patch cords, is that the bundle sizes, when a number of cords or horizontal cable are bundled together for any distance, the consideration is that the bundle sizes might have to go down. Instead of the maximum bundle sizes of 48 or even higher, when using that expected 90 watt level for the PoE++, the consideration is that the bundle sizes would need to drop down to a bundle size of 24, for example, for the 28 gauge cords, to allow that heat dissipation, because the cords being smaller, that puts actually the potential heat elements closer together, and therefore we need a little more airflow around the bundles. So, but absolutely no question about the individual capability of the cords to carry the power without issue. It simply becomes a matter of the bundle size. And 24 as a bundle size is actually a bundle size which is quite commonly used in the industry anyway.
Thank you, Tom.
What's next?
We're going to go forward with a couple more questions. Members of our audience, I know that we've just kept you past the hour mark. If you can hang on with us, please do. We appreciate your attendance very much. If you've got to take your attendance certificate and go, of course, you're free to do that. Thank you so much for staying with us. A couple more questions, though, that came in. Tom, one is asks about vertical patching, the fifth innovation that you presented. With vertical patching, do you have ideas on how one can comply with TIA patch panel labeling requirements, particularly if there are multiple racks of this configuration with shared patch panels?
Great question, Patrick. With vertical patching, the panels themselves are the very same panels that can be used in the normal horizontal orientation. So the panels themselves, whether you choose to use a vertical numbering scheme on the panel or a conventional horizontal numbering scheme where you start at the top left of the panel and you work across in the numbers going to the right, 1, 2, 3, 4, etc. These schemes and these panels are no different. The only difference that we're implementing here is the orientation of the panels, and it's taking them from the typical horizontal orientation in which they sit in the rack going side to side, and we're just turning them 90 degrees. So actually, in that respect, Patrick, the same labeling conventions can be used. The one thing I will say is back to that reference to the density factor, that if you implement vertical patching in that maximum density scenario, kind of like I'm showing here, there's going to be quite a bit of patch cord traffic sitting over those panels. And it might make the labeling something that's a little bit difficult to see. And again, I throw that out there just in fairness. Back to our point at the end, each of these solutions, there is no one-size-fits-all, and it must fit the application. If you're in a situation where you need this much patch port capacity, and you've got one rack in your TR with a little bit of extra space hanging on the sides where you could stick a vertical manager like this, that may be your only option. But it might not be ideal from like a management standpoint, and this is why you wouldn't want to change that every day. You really want to set it up and ideally leave it as much as you could. And this is I'd say practically speaking, that's about the only consideration with regards to labeling. But the labeling on the panels themselves and whatever scheme you're using, you could implement that no differently because the panels themselves are no different. Of course, they will be reading vertically, right? You'd have to be turning and looking at the labeling along the vertical axis. So any other questions, Patrick?
Well, there one more, if I could send your way, and I'm going to perhaps unfairly ask you to speak for Dan, your customer from Nationwide, because you're our Q&A guy. But there's a question came in about that that application in particular. It says in the Nationwide case study, move adds and changes were executed using patch cord repatching. If one was to use the same method and the patching harness, what is the plan for Max for moves, add, changes, or was this Nationwide example a conversion to one-to-one patching?
So actually, let me throw up this slide here showing a good picture of what Dan and Nationwide are using. Again, back to the same length cord approach that Dan was already implementing as a great logistics and time-saving practice. And he is doing, let's refer to one-to-one in this case as simply dedicated port assignment, going from a particular port on the switch to a particular port on a panel. And at Nationwide, there's a systematic approach used for the labeling of each panel using letters. So A, B, C, D for a 4-line card installation, or longer if it's like an 8 or a 6, depending on the size of the TR. Different things are used. But Nationwide does and did already use an assigned port mapping approach, where the switch port went to a specific port on a specific panel in each case, and that's why he was able to use that same length cord. What we did in working with him and what he chose to use was the harness of that same length of cords, so that he got the time savings of having those cords already grouped together and already labeled and running to the same panel ports that he did before. So this has, I can tell you from having personally seen many of the Nationwide TRs, obviously a top-tier national company, one of the biggest in that space. There's a number of TRs across the country, and I can tell you that approach that they use is consistent in terms of that patching mapping assignment, so that in this case, in reality, the moves and changes generally would not be the remapping of an individual port of the switch to a different port. It could be done, I guess, in specific cases, and the harness would support that, in that, as you can see from the picture, the harness is bundled together using some tack-tie or Velcro type material, which is easily movable, and within the length limit of the 6-foot cord, no different than using individual cords, it could be remapped to a different place. So I hope that answered the question on that last one, Patrick.
Certainly. Thank you very much. And thanks, of course, to every member of our audience who attended today, who stayed with us right now until the very end. On behalf of Cabling Installation and Maintenance and its parent, Penwell Corporation, I thank Thomas Baum of Panduit, along with Dan Maynard for his contributions today. We thank Panduit Corporation for their sponsorship of today's webcast presentation. Thanks once again to everybody who joined us today. Thanks to our presenters. Thanks to Panduit for sponsoring. We wish you all a good day.